So in the last class, we discussed about the different modeling techniques in data warehouse, right? We talk about data cube. We talk about, you know, then star schema, constellation schema, and basically we discuss about those schemas. Now today, the first topic is data mart. Now, what does it mean by data mart? Data mart contains a subset of the data stored in the data warehouse that is of interest to a specific business community, department, or set of users. Now, what happens? See, in a data queue, or you can say in a data that we store in data warehouse, that may consist of different subjects. Data warehouse consisting of those summarized data that are organized with respect to some subjects. This data mart is a subset of the data that we store in the data warehouse. And that subset may falling under one specific business community or one specific department. Like, in the last example, I told you that we have marketing, we have IT vertical, we have, say, sales. So there are different verticals, different subjects. Accordingly, we keep the data in different subjects in the data warehouse, right? Now, in the data mart, we consider only any one of them, like, marketing promotions, IT vertical, or finance, or account collections. So this way, we have a detailed knowledge on specific department or specific subject. Hence, we can say that these data marts are some small slices of the data warehouse. They improve end user response time by allowing users to have access to the specific type of data they need to view. And this is basically a condensed and more focused version of a data warehouse. So remember, as I have said, this is a subset, but it is basically a condensed and more focused version of a data warehouse, because here you can focus directly on that particular information or specific information with respect to specific subject that you are interested on, or that where you want to make some decision, right? I hope that amount is clear. Now, questions comes like the differences between this data warehouse and data mart. Data warehouse holds multiple subject areas, while you have just got that this data mart holds more often only one subject area, like, marketing, finance, sales. Then in data warehouse, it holds very detailed information. Data mart again may hold more summarized data, right? Then data warehouse works to integrate all data sources. Obviously, in the data warehouse, if we go through the properties, you have found already that so we keep the data from different sources, from various sources. So we have to integrate those data sources. But in the case of data mart, it concentrates on integrating information from a given subject area or a set of source system. We don't want to integrate different sources, but here we want to integrate information from a given subject area. The data warehouse does not necessarily use a dimensional model, but fits dimensional models. Okay, but while data mart is built focus on a dimensional model using a schema like star schema. Basic differences, you have to remember that, but once you understand their purposes, then you can automatically write the differences. So what are the reasons for creating data mart? First one will obviously why we are creating, because we want to focus on a specific area, right? So easy access to frequently needed data is the first purpose. Then it creates collective view by a group of users. It improves end user response time, then ease of creation, lower cost than implementing full data warehouse. Sometimes for the data making process, decision making process, we don't need the whole data warehouse data, right? We need to focus on specific detail. And that specific detail within a very small response time, we can get it from data mart, right? Then potential users are more clearly defined than in a full data warehouse. It contains only business essential data and less clutter, right? So whatever the data we need, only that data are been there in the data mart. So we need not to focus on a lot of data. We just need to focus on only the data specifically there in that particular data mart. So these are the reasons for creating a data mart. Okay. Now, as we have discussed everything about data warehouse, now let's discuss about their advantages and disadvantages. Advantages, it enhances end user access to a wide variety of data. It increases data consistency. Data consistency is there, right? Once we put the data in the data warehouse, we should not worry about the change, because we do not permit changes on the data that we keep in the data warehouse, because whatever the data we are putting in the data warehouse, they are already in there, you know, uh, summarized version or historical data, because we don't need to put real-time data in the data warehouse. Real-time data, when we deal with, then obviously those data belong to database, right? So it increases data consistency, it increases productivity, and decreases computing cost. Increases productivity because the sole purpose of data warehouse is to help the decision making process, to optimize the decision making process. Once we make a right decision, obviously our company's profit is going to be increased. So increases productivity and decreases computing costs, because if data warehouse is not there, then we have to again access those data, millions of data there in different data sources. But now, as we have already summarized them, we are putting them in a proper organized way specific to different subject. So we don't need to waste computational time to access and retrieve those informations, right? So it lowers that computational time. So it decreases the complexity. That's why we are writing here like it decreases computing cost. Okay. So is able to combine data from different sources in one places, because data integration is one core property of data warehouse. Then it provides an infrastructure that could support changes to data and replication of the changed data back into the operational systems. Right. Now, what are the disadvantages? You know the ETL process, right? So that process consumes a bit time, effort. It's just very much needed because we don't need to put some, you know, mingle data in the data warehouse, some means chunk data in the data warehouse. We want to keep some clean data in the data warehouse. So this process takes time so that we may have the right information whenever needed. We can access it from data warehouse. So extracting, cleaning, and loading data could be time consuming. You can consider it as a disadvantage, but it is mandatory, it is needed. Then problems with the compatibility with systems already in place, like transaction processing system. Are your data warehouse is compatible or not? That is again a kind of concern. Then providing training to end users who end up not using the data warehouse. See, database is for everyone, but data warehouse for those who are working for knowledge creation, decision making. So we may need to train the end users who don't know about how to deal with those data knowledge or how to deal with those some other data in the data warehouse. Then security could develop into a serious issue, especially if the data warehouse is a web accessible. Security is going to be a major concern because now, if you think that data warehouse is a normal database, no, it is not correct, because in a data warehouse, we keep every confidential information about that company, about a particular company. If those information falls into the hand of some another competitor, then that competitor, if not follows right business ethics, that company may take advantage of it, may misuse of those data for the profit of their own company. So security is very much essential once we make the data warehouse web accessible. Okay, so these are the disadvantages of data warehouse, and we have to be very much aware with those things, those loopholes, whenever we are going to take the benefit of advantages of data warehouse, right? So advantages and disadvantages both are there. We need to take care of. No applications. First thing that should come to our mind is the decision making process. Whenever there is a need of decision making, then we need this. So its applications may be in the industries like finance, insurance, telecommunication, transport, consumer goods. So like in finance industry, application will be credit card analysis. In insurance, application will be claims, fraud analysis. In telecommunications, maybe call record analysis, right? Telecommunication call record analysis. Then transport, logistic management, consumer goods, promotional analysis. So there are various applications with respect to different industries where we need the data warehouse, right? Remember, I told you about ETL. ETL, a kind of process that we cannot ignore actually, because once we need to put some data in the data warehouse, we keep it in a clean form. There we need ETL process. ETL stands for extract, transform, and load. What I have said, extract, transform, and load. It is responsible for the operations taking place in the big stage of data warehouse architecture. Right? Extract means get the data from source system as efficiently as possible. Transform means perform calculations on the data, and load means load the data into the target storage. Remember, extract means getting the data from source system as efficiently as possible. Transform means to perform calculations on the data, we need to transform into a particular format. Then load the data. Load means load the data in the target storage. Advantages, it is maybe simple, faster, and cheaper. Still, I told you that it is a bit of costly process, right? It delivers good performance even for a very large data set. And yeah, that is true, right? And it allows reuse of existing complex programs. So that is ETL, extract, transform, load. Popular tools are there for this process, for this ETL. Like from IBM, we have Informix. From Oracle, we have Oracle Warehouse Builder. From Microsoft, we have Microsoft SQL Server integrations. Remember, at least this one is very famous, Oracle Warehouse Builder. Okay. So Informix by IBM, Oracle Warehouse by Builder by Oracle, Microsoft SQL Server integration by Microsoft. These are popular ETL tools. There are many, but I'm just keeping 3 of them. So this Informix is one of the world's mostly widely used database servers. High levels of performance and availability, distinctive capabilities in the data replication, scalability, and minimal administrative overhead. These are its features. And what we do? Real-time analytics. Informix is a single platform that can power OLTP and OLAP workloads and successfully meet service level agreements for ease. So we have to try to meet the SLA. It's very important. Now you can go through this in the website. Asimit, let me show it to you. So this is the Informix. Uh, you just need to go through this site, ibm.com/products Informix. So this IBM Informix is a robust database that handles demanding workloads with easy combining relational and object-oriented capabilities for flexible data modeling, supporting SQL, NoSQL, JSON, and time series data with seamless integrations and high performance transactional processing and real-time AI processing with Watson X. Watson X, you know about Watson X. That is a product by IBM. Similar to this, you can go through the inside of it, what are the resources. So at least go through once, whatever the features available here, right? But my purpose is to let you introduce with this type of tools. So this is one such important one. IBM Informix. So real-time analytics, then fast, always on the transactions. Sensor data management solves the big data challenge of sensor data with unmatched performance and scalability for managing time series data. Then easy to use, then best of breed embeddability provides a proven embedded data management platforms for ISVs and OEMs to deliver integrated world-class solution enabling platform independence. Then again, you have seen that this is capability is not only limited to SQL, it is NoSQL capabilities also there. So IBM Informix unleashes new capabilities, giving you a way to combine unstructured and structured data in a smart way. So bringing NoSQL to your SQL database. So this is one of the very beautiful feature of this Informix. So this is one tool. Other tools also you can search like Oracle Warehouse Builder, Microsoft SQL Server integrations. Now what we have learned is that this is not the data warehousing is not a new phenomenon. All large organizations already have a data warehouse, but they are just not managing them. Right, over the next few years, the growth of the data warehousing is going to be enormous with new products and technologies coming out frequently. So in order to get the most out of this period, it is going to be very important that data warehouse planners and developers have a clear idea of what they are looking for and then choose strategies and methods that will provide them with performance today and flexibility for tomorrow. So these are some important reference. You can take a screenshot. So whatever we have learned about this data warehouse, they're very, essential. Like, we keep the data for mainly the future use or future use right decision-making process. These are few, very important data warehouse. Like this one is from Oracle. Then this one is from IBM. Okay, but you need to purchase, but still you have the option of going to the free trial, right? Free option is there, you can go through it. Then one more is there. Just a minute. This is from the Amazon AWS. It's also very useful. You can go and use the free version also, this one. So these are the data warehouse applications. These are the famous ones: AWS, IBM, Oracle. So my suggestion is that at least you can go for the free version, and then you have an idea, we will have an idea that how we deal with the data in a data warehouse, how we deal with the different schemas. Like I told you about the star schema, right? Star schema. This is exactly how it looks like. Let me show you. This one is very good. Just let me open the yes for you. Just a minute. Like this one. See, in the star schema, what happened? We kept the fact table, and this fact table is associated with different dimension. Dimension, I told you, dimensions means we put the different and the attributes informations. So like if you go for the address, in the address we may have the city information, we may have the state information, we may have the country information, pin code information. So several informations are there. Accordingly, we can break every table into different dimensions only to understand that information in a better way. Like this one also, you can see here example, like fact table, reseller sales. And then there are different dimension, like seller sales may be from different territory, different products, different date-wise sale, different reseller, then different employees. So there are different dimensions. DIM stands for dimension. So our fact table is this one, reseller sales. And this table is associated with different other dimensional tables to understand the information in a much better way. And that's why it is known as a kind of conceptual schema, and as it looks like a star. That's why it is known as star schema. Okay. So in the dimension, star schema, we have two tables. One is fact table. Fact table is a central table in a star schema that stores the numerical data, like, sales, revenue, profit. And fact tables contains fact records, which represent individual transactions or events, along with foreign keys that reference to the associated dimension table. These fact tables throw foreign key associated to the dimension table. I hope that you know about the primary key and foreign key. We have already discussed in the DBMS, right? Then dimension table. Dimension tables are connected to the fact table via primary and foreign key relationships and store the descriptive informations like customer details, product informations, date attributes, and these tables provide context for the facts and are used to filter, group, or categorize the data in a various way. So it is one example of this star schema, right? Now, one more is there. Let me show it to you. Constellation schema. This constellation schema, this looks like this. The it is a fact table. It is a fact table. Work placement and works of both are fact table. Now, this has been associated through different dimensional tables. Yes or no? This is a dimension table. Company is related to replacement, then it's related to students and TPU. Again, the student and TPU are related to, associated to the one more fact table, that is workshop. And this workshop, again, one dimension table, that is training institute. So it looks like a constellation. That's why this schema is known as constellation schema. One more schema is there. Let me show you. This one is known as fact constellation, right? And another is there. Let me show you. Galaxy. This one is also Galaxy. Figures not coming clearly. Let me opening it for you. This is a star schema. Let's see. This is the snowflake schema. And this is, Galaxy. See, this is sales fact table. This is the sales fact table, and this is the inventory fact table. Now, we increase the dimension as many as possible, and from the dimension itself, again, it may be associated with another fact table, like you can see in the constellation. Similarly here, so many fact tables may present, and this looks like a stars galaxy. That's why this term comes galaxy schema. Overall, it is same. Fact tables are there. Fact tables are associated with the dimensions, and then again, those via dimension, those fact tables are associated. Similarly, it goes on. So ultimately, it looks like a galaxy. That's why a galaxy schema. So fact constellation, galaxy schema. The more you have just seen that with these examples, right? They look like galaxy. That's why the term. And then the most important one that you have to remember is this one, that is star schema that we commonly use. I think this is sufficient for today. We have completed the data warehouse part. Next class onwards, we come into our main part, that is the data mining part. So that's it. Thank you.